Alright, so this podcast has to do with atomic mass. So we've learned about atomic number, we've learned about mass number, now we're going to talk about atomic mass. And atomic mass is a weighted average, which is how your grade is calculated in my class, is a weighted average of all of the naturally occurring isotopes of an element. And that should probably just have one R. Occurring isotopes of an element. Alright, so isotopes, again, have the same atomic number, which is why we're talking about an element. They have different numbers of neutrons. So again, the atomic mass is the weighted average of all the naturally occurring isotopes of an element. Alright, that gets kind of messy right there, the way I've written it. Alright, so an example might be to calculate the atomic mass of copper. If copper has two isotopes, 69.1% has a mass of 62.93 AMUs, and AMU is atomic mass units, and the rest has a mass of 64.93 AMUs. So if we were just taking an average, if I want to know the average of 6 and 12, what do? We would add them together and divide by 2. So 6 plus 12 equals 18. We divide that by 2 and we get 9. Okay? What are we really doing when we're dividing this by 2? We're saying that it's equal parts 6 and equal parts 12. So what we could do is we're really saying this is 50% 6 and 50% 12. Alright? So mathematically, if we take 50% of 6, we have 3, right? And if we take 50% of 12, we have 6. And if we add 3 plus 6 together, we get 9, which is the average of 6 and 12. Okay? So mathematically, when we talk about an average and we divide by 2, we're really multiplying each of them by 50 and adding them together. If we had 3 things, we divide by 3, or what we could do is we could take each of them and multiply them by 33% and add them up together, and we'd get the same answer. So what happens is, in a weighted average, we're saying they're not weighted the same. So in this particular example, one of our percentages is 69.1%, alright, which is listed right here. And our other percent, even though it doesn't list it, if we have 100% and subtract 69.1% from it, what we have left is 30.9%. Okay? So what we're going to do is we're essentially going to take 69.1%, and I'm just going to change that to a decimal. It's really 0.691, and I'm going to multiply that by my mass, which in this case is 62.93 AMUs. And I'm going to add that to my other percentage, which we calculate as 30.9, so I'm going to change that percentage to a decimal. So it's really 0.309. And I'm going to multiply that by my other mass, which is 64.93 AMUs. Alright, so when we solve this problem, we get an answer of 63.546 AMUs, or atomic mass units. Alright, and that number, we don't see this one very often, but I'm going to go to a periodic table. And notice copper is right there in the middle, and it has 63.546 is its atomic mass. Well, every time you've referred to that since August, that's been its molar mass. Okay? So the atomic mass is simply what the mass of one atom weighs, and it's in AMUs, which are crazy, crazy small gram values. If we have a mole of copper atoms, which is 6.02 times 10 to the 23rd atoms, it should weigh 63.546 grams. Okay? So why is that a decimal number? Because it's an average. It's taking the various masses of copper and taking into consideration their abundances. Alright? And again, from this problem, we see that 69.1% has the smaller mass, and 30.9% has the heavier mass. But that mass, if we have a sample of it, we're going to assume that 69.1% of it's this, and 30.9% of it's this, and overall that average mass would be 63.546 AMUs, or what we use all the time, is 63.546 grams. So again, it's a decimal number because it's an average, and I think that's all you need to know. Because it's weighted, our atomic mass, whatever mass it's closer to, means we have more of it. Alright? So that's it.